In this video, we're going to be writing a method called trim that we're going to add to an int tree class. The method accepts a minimum and maximum integers as parameters and removes from the tree any elements that are not within that range. So for example, we have the following tree, and we call upon trim 25 to 72. Well, what happens is we trim all the values. We trim all the nodes that are not within that range. So we're going to get rid of the 8, the 14, the 20, and the 90 and the 83. But notice that when we cut off those other nodes, we do not actually lose the nodes that it was attached to. So I believe it mentions it somewhere. Yeah. All right, so let's get started with this. We're going to be returning void as we're modifying the tree. This guy's trim, int minimum, and int maximum. We're going to use the property of x, change x here, in order to modify this entire tree. So we're going to call overall root. It's going to be equivalent to, we're going to call our private helper method that'll take the overall root, so we may traverse through the tree. It'll take a minimum and it'll take a maximum value. So our private helper method is going to return an int tree node here, because we're modifying the overall root, and it's going to be trim, and it's going to take in an int tree node, it's going to take an int minimum, and then it's going to take an int maximum value. So what happens if the root is equivalent to null? Then it just implies that we have nothing to modify. We can't remove anything. It's an empty tree. So we're just going to deal with the case that root is not equivalent to null. So what do we want to do there? Well, what happens if the root dot data happens to be less than the minimum value here? I just noticed I forgot to declare the name there. Oh. If root.minimum is less than the data point here, then we want to actually remove that point. So how are we going to do that? We're going to set root equivalent to trim. Yeah, let's see. Yeah, so 38 here and 25. Yeah, we're going to trim, declare it, set it to the right side here, and that should take care of this thing here. Okay, so we're going to trim, traverse down the right side, pass in the minimum, pass in the maximum. And then in the other case, if the data happens to be greater than the maximum, then we want to do just the opposite of this. We'll set root equivalent to trim of the root dot left, the minimum and the maximum parameters. Otherwise, at this point, we know that we have the values. We know that the values are within the range here, so we're just gonna say, okay, our root dot left is just going to traverse down the left side of the tree. And then our root dot right is going to be a traversal down the right side of the tree. And after all this testing is said and done, we want to return our root. And that's it for this video.